Welcome again, the exciting, ever-fascinating world of chemistry. We're looking at Gibbs free energy. Gibbs free energy is means determining spontaneousness of a reaction, how much it's going to go to reaction all by itself. So if a delta G is negative, we consider that spontaneous. If delta G is positive, we consider that non-spontaneous. So let's look at a problem. Determine the Gibbs free energy for the reaction of methane with oxygen. Methane with oxygen, that's going to be a combustion reaction. Water is formed as a liquid. So let's look at the reaction and let's balance it. So we have methane, CH4 plus oxygen, yields me CO2 plus 2H2O. Don't worry about the forms right now. I'll get that in a second. All right. So because we're going to use the SAS law, same as we did for enthalpy, we need a formation reaction. So again, I said I was going to put the states in. Carbon, solid plus two hydrogens, gas gives us CH4. And I'm asking for delta G, but so you understand the process is the same, I'm also going to give you delta H, enthalpy. So enthalpy and Gibbs free energy. All right, the other two reactions for carbon dioxide is C plus O2 is carbon dioxide, negative 393.5 for the enthalpy, negative 394.4 for the Gibbs free energy. Again, that comes out of the chart, and I attached that in the bottom of this file as well. And H2 plus 1/2 O2 yields H2O, negative 285.83, and all these are kilojoules per mole, and negative 237.13 kilojoules per mole. All right, now, again, we're doing the formation reactions, always forming 1 mole in terms of Hess's law. So I want this from this. So we need to put the product in the reactant, which means we're going to flip the reaction. When we flip the reaction, the signs become positive. So instead of negative 74.8 kilojoules per mole and negative 50.8 kilojoules per mole, they're positive 74.8 for the enthalpy kilojoules per mole and positive 50.8 kilojoules per mole for the Gibbs free energy. All right, so for carbon dioxide is exactly the same. It's on the same side. So we just put it in there, and our values go in just as they are. Now water we're going to have to take and multiply by 2 because we got a 2 up here. When we do that, this becomes 1, and the 2's over there. So we're going to have to multiply the values by 2. So in terms of the enthalpy, that becomes negative 517.66 kilojoules per mole. So the Gibbs free energy, negative 237.13 times 2. All these are kilojoules per mole. So we then add them up. My carbons cross out, hydrogens cross out. I have 1 methane. I have 2 waters. Oxygens, rather, that's what I have up here. 1 carbon dioxide and 2 waters. So that gives us our reaction. So our enthalpy would be negative 890.36. And our Gibbs free energy is negative 817.86 kilojoules per mole. That would be the answer since that's what I actually asked for. All right, so we also value we can find called entropy. Entropy is a measure of disorder in a system. The second law of thermodynamics in the universe, substances go from a state of order to disorder. If you leave your room and don't clean it, it becomes a mess. All right, so how do we find this? Let's look at an equation. This is called the Gibbs free energy equation. Delta G is equal to delta H minus T delta S, right? And if enthalpy is negative and entropy is positive, then the reaction is always going to be spontaneous because the Gibbs free energy will always be negative. Contrarily, if their values are opposite, then the signs will always be positive and the reaction will never take place. We can generate other variations with temperature, and we'll talk about that in class. If they're both positive, the reaction will not take place unless extremely high temperatures. If they're both negative, the reaction will take place except at very high temperatures. So we'll talk about that later in class. All right, so let's look at the last problem. We have the Gibbs free energy and entropy. The reason why I solve them so I can apply the equation. So if we're looking for entropy, we're not going to use Gibbs free energy. We're going to use this equation. So we're not going to use Hess's law. We're going to use this equation. So using our delta G and our delta H we have in the last problem, we find that delta S is equal to delta G minus delta H all over minus T. So put our values in. And we have to have temperature here. So that's going to, let's say it's going to be 38.9. We have to convert that to Kelvin. So that's 311.9 Kelvin. All right, so put our values in, and we multiply through. We get negative 0.2324 kilojoules per mole Kelvin. Don't like that decimal, so we can multiply by 1,000. So it's negative 232.4 joules per mole, and that's my answer. Here's 3 more problems. We're going to do these in class. Calculate the enthalpy, Gibbs free energy, and entropy for reaction of ethane C2H6O with oxygen at 67.97 as product of water is a gas. And then determine the enthalpy Gibbs free energy for the reaction PbCO3 plus HBr gas yielding me PbBr2 plus H2O liquid and carbon dioxide as gas at 18.45 degrees Celsius. And lastly, determine the Gibbs free energy, enthalpy, and entropy at 50.45 for the reaction. MgO plus AlCl3 gives me MgCl2 plus Al2O3. Hopefully that wasn't too bad. We'll be doing this and practicing through them. So take care, be good.